1 parts per million is equivalent to 1 milligram per liter (1 milligram per kilogram) or 1, okay, sorry, I cannot use the word equals to, 1 milligram per kilogram or 1 microgram per mil or 1 milligram. So this is to achieve 1 parts per million, 1 microgram per mil. So if you have your concentration, if your concentration starts with 1 microgram per mil, that is already 1 parts per million. 100 microgram per mil, that is 100 parts per million. So I hope you understand this term, right? 1 parts per million, 1,000 microgram per mil is 1,000. 1,000 parts per million. So this experiment was initially conducted by double diluting. The highest concentration is 1,000 parts per million. So this is the range of the concentration from 1,000 parts per million to 500 parts per million, 250 parts per million. It's not always to double dilute the concentration, but if you do this with zebrafish, in the wells, so you can do the half dilution or double concentration or double diluted to get up to this point. This is only a 6 range of concentration. You can further dilute it to 2.6. Okay, so you can further look into a lower concentration to find the range. So without looking at this graph, let me just delete all of this graph. Okay, so are you with me? Right, this is the concentration given for a toxic compound. We start with the highest concentration, double diluted to half, double diluted or half diluted, 1,000, 500, 250, 125, 6.5, and 325 microgram per mil or part. This is a column for the log concentration. So if you have your calculator, log 3,000, log 1,000 is 3, log 500 is 2.69. So this is the concentration that we normally use to get a sigmoidal or a probit regression line. Then this is the data you obtain from your experiments. For example, at 1 concentration parts per million, now mati, 6 dead. So the percentage of mortality is 60%. And if the mortality is 4, the percentage of mortality is 40%, and so on. So this one, let me highlight again. No insert. There's no percentage corrected. There's no correction. Why? There's no correction. Corrected mortality. There's no correction of the percentage of mortality because they are 60%, and 20%, 10%, 10%, 10%. But what if I start with a lower concentration, which is 16.125, and the log is log 16.125 is 1.20, 1.207, 1.207. What is this? Is the lowest concentration, and the death is 0. So the percentage of mortality is 0%. But according to the Miller and Tainter, before you transform the percentage of mortality into the probit, you have to correct the percentage of mortality. For this case, the number of animals in a group is 10. So based on the formula given by Miller and Tainter, this has to be converted into 2.5%. I think you can recall our previous slides. This one, no, I cannot share now. I have to share. Are you looking at the Excel now? Yes?
Yes.
Yes.
Thank you. So the percentage of mortality 2.5. And based on the can you see the paper I'm using now? No? Can you see what am I doing?
No.
No? Okay, let me just paste this. Copy. Can you see the probit table now?
Yes.
Yes, transformation of fish mortality to probit. Can you see it?
Yes.
Yes. Yes, it's clear, right? So for 60%, 40%, 20%, you don't have to correct the percentage of mortality, but for 0%, if it's 10 animals per group, you have to convert it or correct it to 2.5% that I have shown you earlier. So it's equivalent to 3.04. Whilst at the higher concentration, for example, at 2,000 parts per million, if the death is 10/10, that is 100% of mortality. There's no 100% of mortality, so you have to convert it to 97.5 based on the number of the animals, and the percent and the probit is 6.96, which is obtained by 98% plus 99%. The probit is average 7.05 plus 7.23 divided by 2. So before we can transform the percentage of mortality into this probit. Sekejap, I buat besar-besar lagi. Probit. Before you can convert it into probit, you have to be fraction based on Miller and Tainter. So I think you understand now. The sigmoidal graph is achieved by plotting concentration. You can have a different concentration of this based on one. You can plot this versus percentage of mortality. Insert. Quite a nice curve. This is concentration. This is percentage of mortality versus concentration. We can also plot, which you can get sigmoidal. You can also plot log concentration versus percentage of mortality. Which is quite sigmoidal. But the main thing to be statistically accepted is by plotting log versus, yes, log concentration versus probit. Insert. This is the one. Versus probit. You'll get this kind of quite straight curve. Is this the right one? No. Log. Excuse me. Just delete it. You can get this curve. Log versus probit. Okay, slightly. And from this is the log and this is the probit. From this, you can predict actually the concentration of it. And we can, predict. Have I shown the graph? Yeah. We can actually eliminate one of these. We have a better curve. So at straight line, linear line, display, and this is quite a nice regression line. So you will get an equation and of the probit. This is a probit analysis, the log concentration versus the probit, where 5 is equivalent to 50%. You can simply estimate the concentration of 5 at this around 2.8, or you can just hand drawn and extrapolate, or you can insert the equation. Are you with me? Insert the equation. Copy. Sorry. Just a second. Copy. What's the copy? Copy. Paste. Okay, y is equivalent to 1, 3. We want to find the concentration. Nampak? Y kita nak probit dia 5. 5 is equivalent to 50%. 5 sama 1.3614 x plus 1.0581 x is 5.3614. X is 2.895. Nampak tak X kat mana? Ni nanti kita boleh label 2.895. Ni X. So if the probit 5, tak percaya, 50% of the mortality is equivalent to probit 5. Probit 5. So when we refer to the probit 5, nampak tak ya? We can simply add 5 kat sini kan. So 5 is estimated around 2.89. Ataupun you can substitute the value of y is 5, then you will get the value of x is 2.895. But please bear in mind 2.895 is the log of the dose. Log of the dose. So what is actually dose? You have to anti-log 2.895 to get the concentration, which is 785 parts per million, or 785 microgram per mil. Okay, can you still see me? Because less than 1 minute. Can you still see me? No? Is it clear? Or is it a bit too much? Clear tak?